I'd also like to show where these are actually going.
Yes, that's a good point.
So wherever you have your project, in my case,
It's in desktop and Unity projects, right?
yes. In my case, I have way too much to sift through. That is not where that is. It's in here. You will it was all to your specific project folder. Mine's called Unity Tutorial Test 2. There's an assets folder in here, and this will correspond to whatever you have in your assets window here. So let's see here. I'm going to try and recycle. I'm going to try to find and recycle one of my where is it? Desktop. I'll just put out one of my assets here. Sure. So this is for one of my other projects, but if I just drag this in here, then that image will pop up here once it's reloaded. And you can also go ahead. You also go ahead and create folders, and such. And
you can also drag your images just directly into Unity right there.
Yeah, that's the shortcut we'll go over in a bit.
Yeah, but it is good. But it is good to see like this assets folder in here corresponds to whatever's in here.
Yeah, so you know where the file pathing is. But that's a nice shortcut. Could you drag a different image just straight into the assets folder?
Sure.
You can actually just hover over the assets, or you can even hover over a specific folder, and that'll drop it into the appropriate location.
Yes.
This works with audio files, particularly .wave ones work the best. MP4s, you can actually play a full video inside the game if that's part of your design. Amongst other things, and even assets from other Unity projects. You can just dump it straight in. It's pretty good about that. Even entire Blender files, if you want to do a 3D model later in the game development cycle, you can actually just drag the Blender file into Unity, and it solves everything for you. All your materials, all your messages and models, anything that you grab from the internet, plop it in there, you're good. It'll take care of everything.
Yeah, unfortunately, I don't really have a lot of good ready-made assets like specifically for these, but
that'll be perfect. Don't worry about it. I was literally just going to use Waluigi in a Minecraft block as long as it's PNG.
Yeah.
All right. Is there anything else you want to go over?
There is one thing we're going to want to make sure about. When we're editing scripts, Unity uses C# as its scripting language.
I will go over a little bit of C#. Yeah.
We would. Yeah, but we're going to want to use we're going to want to be able to set up Visual Studio to work with you better.
It should come with it should come with it by default.
It does. It should, but it's probably already set up here. But in case it isn't, we want to set Visual Studio as our default editor. So we're going to go to Edit and then Preferences, and
same way we use Python's idle to edit some of our 1801 projects or something or other. This is just a different editor for C#.
Oh, and apparently this one wasn't set up, so
that's a good thing. So open up your preferred script editor. You can go as crazy as Notepad if you're really living on the edge there.
Oh yeah, because I was using Visual Studio 2019 before, and I got rid of that for 2022. That's why.
Oh yeah. So does everybody have a version of Microsoft Visual Studio there? It doesn't have to be 2022, just Visual Studio in general. Yeah. Under Edit,
Preferences. No, yeah, Edit, Preferences, and that brings up this, and it's under External Tools.
Mm-hmm.
And then this drop-down window basically choose your IDE, choose your editor.
2019.
That's fine. That's perfectly fine.
Mechanically, it won't be that different. All right. So everybody's good on that? Yeah. All right. Perfect.
Yeah.
Anything else you want to go over?
I think for right now that was essentially it. So
All
at
right.
least for the general hierarchy stuff. Now it's time we can go into a few more specific things.
All right, cool.
would
Then
you-
I'll take over components, scripting components, C#, and some physics. Sound good?
Yep.
All right,
Go
cool.
for it.
So there is.
Go.
I'm just gonna write this down for me. We're talking about components. All right, and then we're. No, I don't even need to write this down. I got this. I'm not nervous anymore.
You got it.
Okay, so
Almost done.
let's get back
Don't mess up
into
my
it.
computer.
No. Oh, yeah, you wish I could pay for it. All right, so something I want to go over before we go on is the general flow of how we're going to make complicated game objects, things that do things, players that fire bullets, enemies that bounce around the screen, whatever we do. So I want to overview the square game object we made earlier. A game object is just a generic thing, the thing that does nothing. Everything has a transform, a position that they can go around, and Unity knows that it watches this thing. At base, that's all it does. You can make as many of these as you want. It's not going to really slow down your computer much because it doesn't have a lot of things that it can do. But that's when we start getting to adding components. We got the sprite renderer component right here. This is a component, which is a Unity specific way of saying, here's all this code, let me chuck it into the game object. All the sprite renderer code helps render the image. Pretty straightforward. Then that's where we come to modifying the components and the properties and the like. Right now, the sprite is set to square, which is just one of the generic images that Unity has that you can fill in there. But we can actually choose different ones. We can choose this button right here, look through our project, and choose one of the different images that are around here. Unity has plenty of UI images and the like by default. Or we can look at an image, we open it up, and we can actually, if we click on our game object, drag this opened up image into its appropriate place. This sprite is like a variable, and it takes specifically an image. We can drag that in, and we can actually see that image get dragged in the scene. We can hit play and everything. It's going to be there. So it's just something to keep in mind that this is the component workflow. Shove chunks into our game objects and then modify them according to our needs. We can even do other small nuances, like this color here, white, being displaying its colors naturally. We can shift that around. You can see that gives her a red hue. We can go completely black. We can blot out everything, amongst other things. We can play around with this. There's also small properties. You can honestly figure this out looking up Unity documentation or just playing with it. There's plenty of fun little options here. Flipping around the like. There's some more complicated properties that I won't get into for the sake of brevity. But in general, just know that game components are how we're going to make these objects more complicated. In particular, now that we have this sprite renderer, I just want to show the workflow for creating an empty game object similarly. Instead of creating a 2D object with these sprites, what that's doing is it's making a generic game object and then adding the sprite renderer to it automatically. If you don't want an object that even renders or does some other wacky thing, you can create an empty, which is just a regular game object. Boring game object. It doesn't matter if you add in spaces or whatever, name it whatever. You can see that it only comes with this transform component. That's the default. You can't get rid of it no matter what you do. But we can actually add the component to it. In order to add a component, we click this button right here, and then we start the search for which component we need to add on. In this case, I could add the sprite renderer, and it pops up as one of the results right there. We click it, and we have those same images there. That was just an easier way to get to the same result. I can open this up, drag this in, and get similar results. So with that in mind, we could start adding more complicated components that do things. Just as a little example here, I'm going to add another type of component. You don't have to understand how this works. It's just an example of the workflow. For some physics, we can add a rigid body 2D, which specifically means take this code with physics-based simulations for 2D and shove it into our object. I'm going to click that. There it is.
if we run the game, this now has some physics tied to it. And you'll see an example of that right here. That means gravity, that means force, that means mass. You can actually see it falls down. Simple as that. We add physics to it. It has nothing to support it. It falls down on the 2D axis. With that in mind, there is a lot more that we can discuss in terms of making our own components, which is the next subject we get into. You don't just got to make the drag and drop stuff that Unity already has prepared for you. Unity's there to get all this boring stuff out of the way. We've all been through the 1801. It's a bit of a pain trying to go over the sprite slicing and exact transforms and velocity and whatnot. So Unity has the dirty work done for us. The cool stuff we get to do on our own. So now we start putting a bit of that coding to work. I want to get into adding a different type of component. I'll focus on this object right here, this square object you created earlier. Doesn't matter which one you select though. And I'm going to add a special type of component. I'm going to add a script. You'll see new script pops up. It doesn't have an icon next to it or anything else. It's very special in a sense. If we click that, we start to make a chunk of our own code in C# we attach to the object. This is the same way sprite renderers and the rigid body works. We're just taking this code and we can shove it on as many game objects as we want. No need to reprogram it. It's just the script we can attach to anything. So I'm going to name this player but epic. Doesn't really matter. And after Unity takes a small moment to compile, it's going to reload its script assemblies because it's adding an entire new thing to Unity. You should see in your assets folder a new code pop up, this little document with that little C# symbol on it. That is a monoscript. It's got some Unity-related stuff that we will use and abuse to manipulate our object.
And if I can interject,
Mm-hmm.
When you have your default text envelope set up like we did in Visual Studio, you can just double click on that, open up in Visual Studio.
Exactly. There's more than one way to open this up. If you double click it, it'll open it up in Visual Studio. If you have some other editor, you can access it through the folder. It depends on how crazy or how consistent. Or, Notepad is better. Listen, it's more bare bones. It runs faster. Really depends on preference at that point. Another way to access it is to click on the object. This is the one I want to program more. And I can see the component in the side here underneath the sprite renderer. I can actually double click that there as well. However you do it, we should open up Visual Studio. Is everybody following along so far? Am I talking too fast? Do you think these are good?
As you can see, he's clearly much more comprehensive of this stuff than we've been.
Oh boy, but I am nervous as all hell. Sorry? Oh, you got it?
You're preparing for first use Visual Studio, so.
Okay, you're good.
Yeah, you got it.
Imagine, all right, well, all right. As long as that's all prepared, you should see this. Unity actually, don't be intimidated too much by the C#. We're going to go through this a couple steps at a time, and we're going to relate this to Python. We're going to find some connections here. Oh, sure. Pardon? Big empty space. That is okay. We will talk about that in a second, but I'll come over there first.
Did it just open up Visual Studio by itself, or
Could you go into the Unity project that you had open? And could you, oh yeah, there should be some stuff right here. Could you double click on it again? Maybe it just opened up the Visual Studio.
There you go.
Yeah, there we go. So sometimes on your first setup, it'll just open up Visual Studio, but you can reopen up anything in there. In fact, if I can actually close this with the X button and then look for it in my solution or just go back into Unity again.
Yeah.
Right. So now that we have everything here, something I want to specify is that C# has a couple more nuances than Python does, and Unity has some special work that's already done for us. So to help put these things in one at a time, if I go back to Unity, which is right here, there it is, I see that I have my script here, but it doesn't have any of that cool stuff on it like this chunk of code the sprite renderer has here. It has a sprite as a color. It has a little couple Boolean variables, if you're flipped or not. It has a lot of information on it. We don't have any cool information yet, but we can give it that. So in Python, we will, ignoring all of that other stuff, first off, these usings are the same way Python imports namespaces, the way you import serial in order to print to the console, right? Yeah.
Import the random library.
Yes,
Import
yeah.
time.
So that's all this does. This you can ignore for now. All Unity's trying to do is give you some of its special functions. And now we will pretend that none of this is even here. We are going to go to the top here and we're going to declare a variable. It's important to note that in C#, you should declare variables you want to use everywhere at the top. So in Python,
as per the name, it's very similar to C syntax.
yeah, which is also similar to Java if you've ever programmed in that. But since we're going off of a Python background, right, from 1801, I'm going to try to relate that here. In order to declare a variable in Python, we would say something like score equals 100, right? That's usually where that ends. But in C#, there's a couple more nuances to it.
Yeah.
I got it. First, you have to specify where a variable typically is just an empty box. What do I put in the box? Whatever I want to put in the box. In C#, you have to label it first. Tools only go in the tool box. Christmas ornaments only go in the Christmas ornaments box. If you try to crisscross these, it'll throw an error. You have to be specific. It's sort of an anti-programming bug sort of thing. Got to be specific so you know you're using it right. We have to specify what we want in this box. In this case, I'm going to specify it's an integer type. Simple as that. There is a couple more nuances, though. The first one being who can look at the box? Everybody? Only my family? Or literally just myself? This comes in another modifier you have to put on the variable name, which is simply public. There's two others that we won't even really need to discuss here. Public means it's accessible to everybody. Int means it can store integer values from like negative, 2 billion to positive 2 billion, but no decimals. So you specify who can access it and the data type for variables. The second thing about C# is that when you're done with the statement, you have to finish with a semicolon. So those are the three nuances. Specify who can access it, what type it is, and end with a semicolon. Something to note there.
Or slashes are also how you declare comments.
As compared to the hash sign in Python, we're going to use double backslash. You can tell because Visual Studio likes to paint it in a different color if you have everything set up appropriately. You don't actually have to write down this. This is just a little mental note here. So we have declared a variable and we gave it something. We're giving this script some information to work with. We want to give our player a score for how long they play the game, perhaps. If we go back into Unity, something I want to make a connection with is the
Did you save it?
I did think I saved it. Yeah, that's just Control S. Let me go back into Unity. Okay. Why is it not showing up? Oh, there is a small asset error.
Does it need to be in your class for up top?
I think it does, actually. I need to make that specification. Okay, there's the mouse. All right, perfect. So one more thing. The same way... How do I bridge this? All right. One final nuance. I'm going to Control X that so I can paste it somewhere. This is a class. Did we go over classes in 1801? All right, gotcha. So in here, this public specifies that everybody can use the class. And this little detail right here means it translates to I can use the Unity stuff. Mono behavior is a Unity specific sort of package of information that I'm stealing stuff from. That's all you really need to know about that. From there, I'm going to paste in that public int score right here, actually. Now, with this acting as a sort of container, everything in here is something that player but Epic can do. Kind of like the sprite renderer could do its things. Now we know that it has a score integer it keeps track of. If we go back into Unity, we can see it compile up. We should see this change. All right, there it is. Now, in our player but epic component there, we actually see a score number that's set to 100 that we can modify around.
And
Change it to any other number. If you do it during runtime, you can see that we can play around with this number during runtime. And similar to the other properties, when we stop running, it'll reset to what we had before. This is a property that we can manipulate. This will be the start of making HP, ammo, whatever game design mechanics we want to mess around with in general.
And basically, the reason why it'll show up here is because because these variables are declared as public, so you can see them. If you were to declare it as private, which is another scope, which is a different scope, that would be private. That variable would only be able to be accessed by this file, by this class.
There is a high-level reason for it, but I recommend when you start out programming just to make everything public, just because you don't have to deal with this nuance. If I make a private integer and name it bad score, bad score, you'll see even after I save and compile it, it does not pop up in here. But another minor note, actually, is that you can still see it. There is a small triple dot inside any of these components, the transform, the sprite renderer, the player but epic script. This gives some special options that we can look around with. But the one we care about is the triple dots that are on top of the inspector. Here, we can check debug. This gives us all the dirty information. That's one reason that they do make certain variables private, is to hide some of this ridiculous overflood of information. We can even see we have a bad score. It's not highlighted or anything, but you can view it if you're trying to debug to get the dirty information on everything. But we hit those triple dots at the top of right of the inspector again. We hit normal. Now we have that more condensed, clean information that we actually care about. So just a minor note on how that works. All right.
Something real quick.
Yeah.
I just wanted to say that, like, if you change something in your script and in Unity, so he's got 100 for his score in the script, but he's got it 75 here, Unity will have it as whatever is in Unity.
Unity takes precedence.
Yes.
Mm-hmm. So you can overwrite these things.
That's essentially what you're doing.
Yeah.
If you
What you're
wanna
doing
change
writing
it
here.
later, you'll have to change
You're
it
gonna-
here.
Yeah.
So say if you go here, if you just don't give that a value.
Yeah.
Unity will-
Same case. If you don't want to even give stuff a variable, you can just say public int score.
and then you can set that to the default in Unity. You can do that.
Yeah. It'll spawn, it'll start as a value of 0, but then when you start editing, things will change around. Notably, if you change a property like this, Unity will recompile. We used to have a 75 here. Sometimes it keeps the 75 if Unity can recognize, oh, this is the same variable. If you change around a name or something and it recompiles, it'll start at 0 again. Just something to note about the connection. Point being, much like the sprite render and transform, we can make our own components and we can make our own information to attach to this object that we actually care about. And then we start to get into the more fun nuances. So there is a really big upside of stealing some stuff from Unity. So you guys know what methods and functions are naturally, encasing a block of instructions so you can repeat it over and over again. Because specifically we're stealing from mono behavior, that means Unity's watching you. It's watching this script. It's waiting for it to do something, poking it with a stick, waiting for the next thing to pop up. When it comes down to that, there's a couple of very special functions that Unity is constantly calling in order to check up on it. In other words, starting out with this void start function, anything you put in here, Unity will perform as soon as the game object is added to the scene. Or in this case, it's already added. So when we hit play, it's going to execute information around here.
It's your initialization routine.
Yeah, similarly. So something I could specify is we can call all sorts of wacky code here. I could say, just as an example, we'll take the score variable we have, and similar to Python, we can do equals score minus 10. This is going to decrement our score by 10 as soon as we start. We can go over to Unity, let it compile, and we can see, although we start with the value of 75, we hit play, It's going to compile and decrement that down to 65 right away.
So it doesn't keep decrementing.
Oh yeah, it only did that on the start. So as another example, I'm going to showcase the update function right here. I'm going to copy and paste this code over here actually, and I'm going to do score equals score minus 1. I'm going to save, because you do have to save in order for it to recompile. I'm going to go back into Unity. I'm going to start reloading script assemblies. The update function updates every single frame that Unity runs. Ideally, this is 60 frames per second. If your computer starts to lag out a bit more, you won't see this decrement as much. But you can you can actually freeze it for a bit. If I click off, it's still decrementing 1 for every single frame this computer runs. Now it's at negative 7,000. It's going to negative 8,000, and so forth.
Of course, it's being updated at a lower rate than what's actually happening.
Yeah. So
That's just a UI thing.
The inspector only updates like every second or so with new information, so it doesn't crash. It keeps the whole simulation in there. But the game is going tick, 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 tick. It's going for it. It is absolutely beelining it. All right. The other thing, now that we know how Unity can call and start associating things with this object, it can start looking at it. Other components work with this too, by the way. They have that same on start on update thing. We can start playing with it a little more in detail. So this is creating our own properties and manipulating them accordingly. But I want to get even more from the player. Let's give them, I'm going to change this to I'll just keep that as is. For now, I'm going to go over receiving input straight into that. Firstly, any object that is currently updating can do this. If you make a game object, you have a script in it where it's constantly checking per frame, you can accept input on that frame, naturally. So there is a special set of functions, like accessing the random library, random.randint for Python-related stuff. There's a special Unity library called input. Why is that not showing up? Do you have the documentation?
Documentation.
Okay, give me a second.
I should also say that for double checking setting up your inputs in the UI, you're going to want to go to edit project settings input manager.
Edit project set. Oh, you mean the horizontal vertical thing?
Yeah.
I feel a bit nervous because I'm not seeing the input dot. What was it again? Shoot. Okay, I ran into a bit of a. Can you pull up the exact? Actually, no. This is a great opportunity. In order to look up something we're looking for, this is actually a big feature. Is that Unity has really good documentation, and I do not exaggerate. You are not expected to know every single function. You are expected in 3801 and 3802 to be able to just look up a documentation, and Unity's documentation makes that pretty easy. We look up Unity documentation, it's user manual right here, even if it is a version behind. There's a lot to look through. It seems really intimidating, but I could simply go as crazy as, hey, I want keyboard input. It'll search that manager and it'll give us everything we need.
And as you keep going through with this manager, you will need to have a lot of experience with reading documentation as you go. So.
Yeah. And what this will do is it'll tell you what the class is, and then you can look at various different properties of that. So all of these are a subset of the input manager. Input manager.name, input manager.dead, .sensitivity, .type, .access, .joinum. What I'm looking for is this stuff right here. Input.getKey. All right. So I was typing it right. I just didn't see the autocomplete, so I got a bit nervous. We can go as far as to copy and paste the line in. That's perfectly acceptable. The wheel's already been invented. Why invent that again? It's going to be input.G at capital key E. This will search for the input key A when that's pressed on the keyboard. And all the function does is if it's currently being pressed on this frame, it'll return the number 1 or true. If not, it'll be false. That means by itself, this is checking for A and returning a 1 when we're pressing it, but it's not doing anything with it. but we can actually do a little bit more. I think that it's similar to Python. An if statement, I'm going to wrap around here, actually. If input key is A, I'm going to get rid of the semicolon there because that's another small nuance I should mention. There are no semicolons for the if statement. It's just where do I go next, not an actual execution of stuff. That's weird. Oh, I held the shift button for too long. All right, I'm going to hold shift. I'm going to hit the opening bracket. I'm going to hit enter. An important difference between C# and Python. Things are not indent based. I could write code right here and it'll still execute perfectly fine. But what's important is
not that statement.
it's not recommended because it's ugly, but you don't have to make things perfectly spaced. Instead, they just have to be inside a bracket container. So the way this public class has a bracket here and a bracket there, it's all inside of that container. The way all of this is inside start, the way all of this inside update, the way these and this, that's everything inside our if statement. So you don't have to worry about indentation in C#. But now we have something, we are getting input from our player. Let's showcase that with another very essential function. You know printing to the console, your first Hello World program, right? This is going to be similar, actually, except there's a library called debug in Unity. This will let you actually print information to the debug window that Paul mentioned earlier. That's over
To the console window.
Yeah, over to the console window right here. So you can actually print your own error messages and the like. It's pretty useful for
Print
debugging.
also works.
Print also works.
But
It's short notation.
Yeah, this is the fancy way of doing it.
Oh, we are accessing Unity's debug library, and we're accessing the log function. Inside of here, all it needs is a pair of quotes. I'm going to say goodbye world. That's perfectly, that's acceptable. That will get sent in. All this code is doing is every frame is the A button pressed on this frame. It'll return a 1 if yes, a 0 if no. And if so, we're going to print that message to the debug log. I'm going to save. I'm going to go back into Unity. I'm going to hit play. The start of getting input from our player right there. No more tracking complicated key codes amongst other things. If I hit A, you'll see that message pops up. It'll tell you what time it popped up, and more importantly,
it also because that was happening in the loop for the number of frames you held down the A button, it'll also display that message that many times.
Yeah. So you see this number right here, that's 1. A Visual Studio is available, blah, 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 blah. That message popped up 1 time. This message popped up 121 times. In order to see that to a more extent, like if it's the same error message, then it'll actually stick them together. If I hit the collapse button right here, you get to see every time one of those messages pop up.
And that's just because it was in the up.
Yeah.
Yeah.
Something to notice is that you have to click on your game in order for your keyboard input to focus on the game. In other words, if I'm over here editing things and I hit the A key, now that's not bringing up new messages. It still says I have 121 notifications right there. But if I click on the game now has priority. If I hit A, now that number starts to tick up. I have 999 plus undismissed info messages. If I hit play to do that again, if I hit the clear button, that will swoosh away all of my problems. You can also hit the arrow right here and do a clear on play, clear on build, which means it'll clear the error messages every time it runs again. So that's how you use the debug log, and that's how we're going to be tracking stuff. You could debug log your score to make sure it's working properly. You can debug log certain informations about the transform or rotations of objects or even other objects. Plenty of great uses for debug.log and the update and start functions.
I think you messed up the syntax a little bit.
Oh, yeah, of course.
Also, if your if statements and the like are only one single statement, you don't actually need the brackets. But if they're more than that, you do.
You technically don't, but I'd recommend a good programming practice to keep the parentheses in here. Visual Studio will also keep pretty clear indications on what container lines up to what. So if I make a really silly mistake, I add an extra bracket right there, all of a sudden, you can see when I click over it or I highlight it, it actually highlights its counterpart to what it's compared to. so you don't get thrown off on what it's supposed to be with. If I delete that, now you can see it's actually paired up to this one again as it should be. This bracket is paired up to this one, and this to that. So just a minor thing on helping make sure you get your bracket containers right. All right, so that's getting input from Unity. That's using its start method and its update method. Now we can actually delve into a couple more of Unity's built-in things and make a game out of it. We know how to receive player input at this point. We can get a specific key, or we can use some other I feel like going to the move axis horizontal is a little more. So I think just working on this for now, I'm going to go over referencing another component. We can reference the stuff in our own script just fine. We are able to reference our own score there just fine. But what if I want this script to talk to the sprite renderer, or I want it to talk to the movement, the transform? You can actually reference your components that aren't inside the script. In order to do that, we just have to tell the script, hey, you have this thing you can interact with. Give it to yourself, you know? In other words, we give it an integer, it knows it has an integer that we can interact with in the inspector. If we give it a transform component, that's like another different data type. Instead of an integer, this is an entire component. And that means we can modify it in the script. To put it more bluntly, make sure it is public. Everyone can access it. And we will make as we look over here, we want to modify its position. I'm going to look for the transform component specifically. So I'm going to make a public transform, and then I'd like to name it Big ET. I don't know. I'm just going to call it Biggie. Why not? So now we have a transform variable here that we can actually edit. It should work if I go into here. Next to score, please work. There it is. We see a new variable in here. It's not an integer or anything. It's a transform component, actually. And that means it can manipulate whatever transform we drag in there. We're just trying to tell it what it is. In other words, we can actually take any transform component and put it in there. It doesn't even have to be on the same object. This square could take this thing, and if I drag in this game object into here, you don't got to do that. But if you were to, it would start talking to a different game object. It would look for the transform component on that object and say, that's what I'm talking to. For the sake of simplicity, I'm just going to drag itself into it. Now it looks at itself, it looks for the transform component, it finds it. That's all you have to do in order to reference it. So now, all we've done is we wrote, hey, you have a transform, and then in the Unity inspector, we dragged in which transform it was talking about. That's it. So now we can actually modify the biggie. In update, let's add another thing to, and this is why I like to use the angle brackets, is because you can add more stuff in later if you feel inclined. I am going to add a new line of code. Now, Unity has its own properties within its component. If I reference the biggie, I can actually look that it has the position variable, the rotation variable, and the scale variable. That actually lines up with what its actual variable names are. I want to go in here. I want to talk to the biggie. Dot position plus equals, there's no easy way to explain this, but the position variable is a vector 3, which is a combination of a vector 2, I mean, because it's 2D, which is a combination of two floating point variables that track its space in the world. Every transform has an x, a y, and a z. That's it. So I'm going to take the dot position and plus equal a different vector 2, which is a shorthand notation for add the x to the x, the y to the y. That's it. I'm going to make adding a new vector 2. This is so weird explaining. Now I realize there's a lot more nuances in C#. I'm going to add a new vector 2 to it of 0.1, 0.1.
You'll get all used to this once you take a real-time interactive from one.
Explain this a little bit more step by step. The same way we can make a new integer, we can make a complicated variable like a vector 2, which is what Unity uses to track stuff. There's actually a shorthand note. When we make it, we have to specify what it's made with. I am making a vector 2 with a 0.1 and a 0.1, which means it's just a little bit of information. X equals 0.1, a y equals 0.1. If I set the position of this, it would move to that world location. What I'm doing here is I'm actually adding it to our position. A plus equals is a shorthand notation for just slapping these vectors together. If I'm at position 0, 0, and I add 0.1, 0.1 to it, it's just going to move up into the right a bit. So that's a little fun
You could have
shorthand.
also done the same thing with the score there.
Same thing. I could do plus a score plus equals 10 or minus equals 10.
If score
Let's give us a
score
result.
negative equal 10 would be essentially what essentially
Yeah.
the same thing as that.
So sorry for the shorthand notation. Just wanted to condense it a bit. I could also do big E dot position equals big E dot position plus new vector, one way or another. So
I mean, that notation's the same way.
Yeah.
Icon.
it's a little bit messy, but we made a new type of thing, and then we told it what that thing was supposed to be. Whenever you make a new thing, you're supposed to feed it some information on what it's supposed to be. And that's that. Now, if I Control S and I go back over here, let it compile, I have a minor mistake there. Whoops. One more thing is the distinction between doubles and floats. Just put an F here. There's actually a distinction, but like how we could have declared an integer right up here for a score, there's a couple more data types called a double and a float. A float only uses like 32 zeros, I believe it was, to keep track of what the number is.
It's a 32-bit number.
Yeah, a double is a 64-bit number, so the data type is a lot bigger that can actually fit in there. Unity
Floats are a
uses
little
floats.
More complicated in how they're set up.
Yeah. In other words, a double
beyond
could,
the scope of what we're doing.
where an integer stops at like 2 billion, a double can go, it can contain a really huge number. But because of that, it actually takes up a lot more memory. That's why Unity likes to use floats. Just a smaller thing. All you have to do is the difference between a double and a float is this is a double, put an F at the end of it, and it's a float. That's it. So a lot of nuances to C#, admittingly. But with all of this together, that one line of code, give me a second. Ambiguous types of vector 3.
Once you take systems programming, that'll be
This is
your
my
first
mistake.
main introduction to most of these concepts.
Right. This is my mistake. It can't actually add a vector 2. It has to be a vector 3. A small little nuance of Unity is that it actually is ready to go 3D all the time. But for its 2D, there's still, how should I explain this? There's still an X, a Y, and a Z. We just don't care about the Z anymore. That's all. So I'm just going to add in a 0.0f for the last parameter. That's it. Vector 3, 0.1f, 0.1f, 0.0f. Now we compile. Let's see if there's any errors in the console log. Yeah, no, we're all good. Just a couple generic Unity things. I'm going to hit play now, and I'm going to attempt to move our character with the A key. There he goes. So it is moving it by only 0.1. If you look at the position variable right now, you can see it's at negative 4.45 and 1.71. You know, as we drag this around the inspector, you can actually see that X value increase from negative 4 to 0 to 1 to 2. We're doing that with input now, every single frame. Another little detail to note, and this is something, you know, we talk about in Pygame, is multiplying things by delta time. I'm actually going to, so you can see a little easier, I'm going to scroll in a bit. Is that better? All right, there we go.
Actually, I think maybe it'd be better if I turn down one of the lights a bit.
Oh, yeah, sure, of course. This is doing it every single frame. That's why our character just speeds off into oblivion. They're still alive. They're still safe. But in order to slow this down a bit, we're going to use what we learned in the Pygame programming class. We use delta time to track how much time has passed since the last frame. So we only move it at a specified rate. In other words, every second, it'll move by 0.1. Which will be a lot slower and a lot easier to track. Instead of every single frame, 60 times it moves 0.1, which is maybe just a full, just beelining it down 6 units every second, just off the screen. So let us multiply it with another library. I'm going to use an asterisk to represent the multiplication. I'm going to do time dot delta time, typed in camel casing. You'll see it as the same thing as the amount of time that's passed since the last frame. That's all you got to do to it. Do the same thing over here.
The update function by itself is going by your computer's variable frame rate. So delta time is a way
Yeah.
to sync things up.
So if you're trying to run this on like Windows 86X and your computer only updates like 4 times a second, then it would only move 0.1, 0.1, 0.1, 0.1, and then it would stop. But with delta time, it keeps track of how much time has passed since the last frame. So no matter how fast your computer is, they all move at the same rate.
Yeah.
Just like we did in Pygame to help sync up frame rates and the like. All I'm doing is accessing time, and it's .delta time. Another way to do it is to make a DT variable equal to delta time. Makes it a little smaller, but that's just programming nuances. This will work, should work. If I hit play, our character should only move by 0.1 per second because we multiplied it by the delta time. If I'm reloading this up, there you go. You can see them moving at exactly a rate of 0.1 in the positive X direction and 0.1 in the positive Y direction. And that's that. I stop holding A, they stand still. As soon as I press it again, it starts doing that again. We can start to move our character around with this. There is a couple of easier ways to do this, and actually a way that makes it compatible with Xbox controllers and the like, stuff that you just want to plug in there. And it all uses the same line of code. Now we're going to start talking about the input.move axis. This basically says, are you a computer? I'm looking for the WASD keys or the arrow keys. Are you a PS4 controller? I'm looking for the thumbsticks. It'll look for these axes, and no matter what you plug into it, you could play this game with an Xbox controller. No extra nuances needed. In order to specify this, I think you had notes on where it was, right?
I do. It should be. Let's see. Go to edit. It's in project settings. Edit project settings in
All right.
manager.
Edit, project settings, and then in input
There it is.
manager, which is just a few clicks down from the top. Now, here, there's various axes. What these mean is no matter what system I'm on, I'm looking for this particular name that I can call in code. Instead of if they inputted the key A, I'm going to ask if you inputted the horizontal axis. I'll show the code for that in a bit. But essentially, when I'm looking for the horizontal, the negative button, or the value that returns a -1, would be left. The positive button would be right. There is a small dead zone where on the controller, if you're standing it still, it doesn't actually take in any input. If it's only 0.1 of the way to the point, to like the full rotation, it's not going to do anything. You can set small nuances like that. The X-axis, getting the motion from all joysticks, key or mouse button, whatever the case is, it actually just absorbs it all. This is the horizontal and accordingly the vertical axis, which will take your down and up keys. Specified as, there's also an alternative here, the S and W buttons, which, WASD standard controls. It'll pick that up. You can see the same thing in the horizontal axis, how you can use left or right, but you can also use the A or D keys. So to sort of encompass all of this, we're going to use what the Unity documentation declares over here, input.getAxis. And then you saw we were looking at that horizontal string earlier. We can type in the same name and we'll get the same results. All we really need is this line of code right here. Is there actually a Discord server that I can paste this into, you think, Jason? We all have? I'm not going to open up your Discord for you. I'll type it out with you guys. So this was our input.getA key. Well, small.
They can also go to documentation.
Yeah. If you guys want to do it that way, however it is, I'm going to give you some time to do it. Another little thing about Visual Studio is this has served its purpose for showing us updating and taking input. So I'm going to highlight all of it actually, and there's this small button near the top with these green lines on it that says comment out selected lines or Control K. I'm going to click that. Now that's commented out. It's there if we want to look it up for notes later. It's there if we want to bring it back in for debugging and other testing. But until then, I'm going to replace it with this more complicated code we've been talking about. To break this down, we are declaring a new variable inside of the update function. The variables that we declared here, you guys have been able to see, they're changed. The object remembers them. Everybody knows what they are. They're public. They can be accessed by everything. This is a private variable because we haven't proclaimed it public. The default's private, which means it won't take up space in our inspector. This is just the name of it. It could be whatever you want it to be. I could call it hizzy and then have the same effect. And then this is the function I was talking about earlier. Instead of input.getKey, we're getting an axis. So controller, keyboard, whatever it is. And we specified what type we're looking for earlier. Now, hizzy is going to return to us a number between -1 and +1 based on what keys or joysticks we're pressing down. In order to exemplify this, I'm going to do another debug.log. And inside of it, I'm going to just print hizzy so I can see the float variable there. I'm actually going to connotate it with a plus, quotation marks, space, and say horizontal output. You don't have to do it exactly in this way as long as you're debug logging the hizzy. You can actually combine a string with a float and or another data type, and Unity will do the heavy lifting of combining that into one comprehensive string. So that's all I'm doing. Input.getAxis horizontal, notably capitalize here and here and here, does have to be case sensitive. And then I'm logging this thing, whatever I want to call it, into the debug.log. So let's go back into here with that compiled. I'm going to hit play, and we should be able to see our picture won't move anymore, but we should be able to maneuver into the console window right here. Right now, it's currently printing that we have 0 horizontal output. If I click on the scene to make sure I give it priority, as mentioned before, and I hold the D key, that number jumps up to 1. If I let go, back to 0. If I hit the A key, it goes to -1 accordingly. And the same thing also happens with the arrow keys. If I hold left, it goes to -1. And if I hold right, it goes to +1. And it always takes a little bit to return to 0. It goes from 1 to 0.5 to 0.3 to 0.2 to 0 accordingly. So that's how we edit this stuff around. If you guys had a Microsoft game controller, you could plug that in and get the same result for changing the left thumbstick to the left or the right. You can do similar thing with the X, Y, A, and B buttons on there, or the mouse buttons.
Provide they're set up correctly in your input
Yeah.
manager.
So
Which you can configure for whatever.
in order to change that stuff around, just as an example, I can go into Edit, Project Settings. I can go into the Input Manager as previously discussed, and I see this horizontal thing and the vertical thing right there, right? We were talking about horizontal a little bit before. I see a negative button and a positive button for that kind of stuff, but what about instead of the letter A, I just want to be really mean and make sure the player uses Z. That's it. That's all you have to change.
Should be use sticky keys.
Hit play, just exemplifying it. I hold A, I'm not getting any horizontal output. I hit Z, now that's giving me the negative horizontal output. So you can configure this based on what kind of controllers you'd like. So you don't have to go into the specifics of every key. You can do that if you want some functions. Maybe you press Z to attack or the space bar to jump or something specific. But you can also map it so no matter what controller your players are using, they get similar results. You could remove the arrow keys as movement options, as alternatives for the horizontal, or even make your own new axis.
This helps for introducing some flexible indirection to your projects. You're just not hard coding everything.
Yeah, whatever the case. And this applies to the entire project. Everywhere you cull that horizontal, you'll be getting this. So that's pretty cool, but let's move around our player with this input now. Simply going to take our biggie.position, and I am going to add the, how should I put this? So position is a vector 3 as I've described earlier. It has this X, Y, and Z. It's its own type of data. But we can actually access a specific part of this data. This isn't typically the way to do things, but there's a lot of ways to skin a cat. There's a lot of ways to get to the same result in Unity. And this is just one of them to exemplify the transform component we've been accessing. I'm going to access the position, the vector 3. I'm going to hit dot again, and then just access the X variable. Now, I'm going to add my hizzy to it. Whatever number we get from a -1 to a 1, I'm adding it to the X position every frame. Well, I don't want it to speed off into oblivion, so I'm going to do what I mentioned earlier and multiply that by time.delta time. camel casing accordingly, lowercase d, uppercase t. Don't forget the semicolons, and we're good. I'm going to save that. I'm going to go over here, and now it should move at a. Oh,
Now there's an error.
whoop. Cannot return because it is a variable. I messed up. I know what I messed up. I apologize. All right. This should be a function. I'm going to take a quick 15-second break to make sure this is how this works. Transform. I can admit when I'm wrong, just to make sure. Position, x+, translate. Where is the functions? Those are rigid bodies. Objects, position. Okay. So this returns it. I am going to do what I did last time. That's my bad. I'm just going to make a same thing as before. I'm going to add a new vector 3 to it. In other words, I can't actually just access the variable right away. It has to go through this function in order to make sure it doesn't break. It's a small little nuance. This is supposed, as we discussed earlier with the 0.1 here, this is the x, that's the y, and that's the z that we don't really care about. So I'm going to add the his times time.delta time, 0, and then 0. That's it. So we're making a new vector 3 and then slapping them together. If we go back into Unity, all right, let's check it out. So now if I hold the D key, my character starts to move forward at a rate of exactly 1 x unit to the right. If I hold the Z key, because I messed it up earlier on purpose, naturally, my character starts to move to the left at exactly 1 unit per second. Because we have the delta time in there and because we have the input, we're slapping in the vectors, that's all you need. I can do the same thing with the arrow keys accordingly. Now we're starting to get some movement in there. And you can multiply this by other things. You want it to go faster, then we could multiply this by a 5, or say we could, another common practice is to make a sort of variable to control this. Let me make a public float, spelled accordingly, called speed. I'm now going to take the speed, and I'm going to multiply it over here. While I'm changing multiply by speed, I declare a speed variable inside the player but epic script right here. So I'm going to compile. I'm going to go over to Unity. We should see the speed pop up in the player but epic script right here. Right now it's at 0. If I hit play, that means our x-axis is being multiplied by 0 every time, which means I don't actually move anywhere. But I could edit this to say 2. Now the normal movements multiply by 2. There's a little bit of startup as the buttons begin to get pressed, but now we're moving faster. I'm going to make that a 5 because I think that sounds about right. And our characters have, this is a lot more easy to work with, a lot more fluid. I think this is the speed that I want for the character. I'm going to hit play again. Our changes went back to 0, but that's where I'm going to make it back to a 5. And one more thing. We're just going to duplicate the process for the vertical axis. Has everybody gotten to that point so far? Your character's able to move back and forth? All right, awesome. So I'm literally just going to copy and paste this and change a few things. You got to be wary with copy and pasting, but I'll go over it twice more to make sure everything's there. I'm going to call this Visi instead. It should be a different variable. It doesn't have to be technically, but if you're declaring a new one with a new type, there it is. And I'm going to make it, instead of trying to get information from the horizontal axis, I'm going to get it from the vertical we specified earlier. Now it has a number from -1 to 1, but only for the W and S keys, only for the up and down arrow keys. Now we go into the position. I'm going to do a similar thing, except this is the X coordinate. I don't want to add or subtract the X coordinate when I press W and S. The X is not getting updated. I want to add to the y-axis. You can even do this in one line, but this is just to better show the changing of the positions right here. This is the x, this is the y, this is the z. So I want it to move up or down. Visi, not hizzy.
Like a careful
There we go. Yeah. I'm changing the y-axis this time. I'm asking for the vertical, and I have a different variable name. And I'd also like to debug.log our Visi, and then I'm going to change this to vertical, just so we can make sure we're getting the right thing. So that's it. Big.position plus equals a new vector 3. 0x, I'm moving it by Visi times delta times top speed on the y, and then I don't really care about the z. And I'm just logging what it was every frame. So we've been talking to our components through the script, and our components talk to the script, and the script talks to our components and our input. That's all you really need to start making a game. Is now, if I hold the various buttons that I've leaned out, I can explore around my game world. We've got a lot set up here. You can start making stuff with this. Game jam in a couple hours, you guys are there, you know? We can make something with this. But a couple more small discretions about how game objects work when it comes to parenting and prefabs. So this is another important part of workflow. And you can see in the console, we have the vertical and horizontal outputs accordingly. Just a fun little nuance right there. Seeing it change around and whatnot. Clear it. There we go. So we want to not just have this be the one object. Check this out. If I hit the delete key, all that progress is gone. It's just gone. It's in the hierarchy, so I can Control-Z it back. But if I delete something like this picture or the like, it's not going to come back. That's just a little fair warning. The hierarchy, you can Control-Z. You cannot Control-Z deleted assets because it's just removed from Unity entirely, where this is something that Unity can rebuild in a sense. Well, I don't want to accidentally delete this, or maybe I want to save it for later or make copies. I want to keep this for redistribution or other things. Our little player right here, I'm going to change the name right here to player thing. Why not? And that is where Unity's one of Unity's big strong points comes in, a prefab. All we do is we take our object we've worked so hard on. I'm going to, after I've clicked it, I'm going to left click and drag. I'm going to hold it and drag it into our assets folder. Now it makes a very special version of it called a prefab. You can see by this little square right here. Prefab is sort of saving the information about the object so we can make copies of it, we can delete it, we can play around with it. You can tell this is a prefab again because these things, there's only one version of it. It's not saved anywhere. This, there is a blue square right here and the text is highlighted in blue, which means I can delete it and not feel bad about it because I can drag this prefab back into the game world. You can see it actually gets added right there with all the same information, the same score and speed that we had last time we played around with it.
They're especially useful for when you're working in a 3D environment when you have different meshes and materials and such.
Exactly. You can make one prefab of a barrel and then copy and paste those barrels everywhere. Explosive, whatever, just throw them around.
If we have time by the end of this, I can quickly show an example of that in one of the 3D projects I already have set up in here.
Of course. So the only thing I want to showcase, which is where, again, Unity comes in pretty strongly, is that I can drag out these prefabs and make as many copies of them as I want to. You can see player thing 1, player thing 2, as Unity automatically begins to annotate them. All of these guys have the player but epic script. All of these guys are listening for input and updating every single frame. They all send that message at the debug log at the start, and I can move all of them at the same time. Because they're all following the same rules. This is a prefab, it's a copy. So if your player dies, you could delete it from the hierarchy and then spawn in a new one. You could deal with multiplayer related mechanics, or just have fun with 1,000 different cubes thrown at each other with a physics simulation. There is a lot of fun different things you can do with prefabs in general. A couple of nuances to say though. Yeah, if I click around on all of these things, you can see that the game object is referencing, this is referencing player thing, which is itself. This tells you that this object is attached to the player thing 1 itself, and so forth. So just an important distinction that whenever you're trying to reference a component in a script, it'll tell you which game object it's actually talking to. I could click on and drag player thing 1 into here, and now this script is affecting player thing 1, but not player thing 2. If I move around with this as an example, you can see one of these is moving twice as fast because it's receiving instructions from this script and that script to move it. But this one isn't moving at all because it isn't talking to itself. It's talking to a different one. We can see in the scene, this one has player thing 1, which is this one right up here. Little minor thing is just keeping track of those game objects in general. Secondly, I could change properties on these prefabs. Like I could change this player score to 1 million, and this will not change the other prefabs, the other instances of them. They all have their own unique positions even, you can see right there. And even more so, the prefab is separate from the instances of the prefab. This is a creation from a recipe, but it is not the recipe. The recipe is right here, and it says the score is 75. That is not going to change no matter how many of these I drag in there. But I can edit it afterwards, and it can save that information even, but it's not going to update the recipe. I made the recipe, and then I changed your score to negative 1 million because screw you. There it is. So that's just a smaller nuance. The second thing is that you can, if you want to change more information about this, you can double click it and it'll open it up in the scene by itself for various editing purposes. This means we could change around the picture of it to something else. Let's select our other image right there. We can change around any of its other variables. We can make the speed down to a 3, and this will update all future prefabs made with it. Right here, the hierarchy is replaced with everything that's just associated with this object and with this object only. If I go back, you'll see that these things have all updated accordingly. They all have that, they do keep what they can, but some things change. It becomes a little bit awkward. When you specify certain things, it'll keep it. I told you to have negative a gajillion, so it remembers that. But it updates what it can without creating errors, basically. So now this is updated the image because it doesn't see any problems or bugs with that. This, for some reason, has not updated. So just be careful when you're making new prefabs. And naturally, if I drag a new one out to here, same rules follow. I can mess with the numbers, and that doesn't affect new copies. So yeah, difference between the prefab is the recipe, and these being the meals created from the recipe. That's that. So one more small thing I want to go over with prefabs, you can also highlight, drag, and delete multiple at a time, is that I want to go over parenting. Inside of our scene, I think I accidentally deleted the main camera. I deleted the main camera. Whoops. We need that. All right, so I'm going to Control-C that back. Here's our main camera. It's in the center. That's why when I dragged over this camera, it deleted. A little fun fact, you get to see a little preview of what it looks like when you drag around the camera there.
Very useful.
Yeah. You can select them individually to delete, or you can actually just click, shift, click, and then hit the delete to just mass get rid of them. I'm going to take player thing, our one guy, put him in right here, and I'm going to parent something to him. First, I'm just going to drag another little shortcut. I'm going to create some more objects. If I drag just the image in here, it automatically will create a sprite and a transform for it. So instead of creating the empty game object through here, you can also just drag in stuff, and Unity will try its best to make it a comprehensible game object. I'm just going to drag a couple of these in here to get a general sense of some things. I'm going to take this main camera and then drag it into player thing. What this does is it establishes a parent relationship, a parent-child relationship with another game object. In other words, game objects can be attached to other game objects. In this case, if we attach the camera to player thing, that means this will follow around our player where it is specified. To put it in more detail, if we move around now, the main camera is a child of it, I could start moving around and the camera will follow me. I'm not actually changing my position on the screen even, but you can see by these other images that I'm moving around in world space still. So that's an easy way to follow around your player. Just make sure your main camera follows that. Notice that the player thing's transform, it's X and Y right there, that 0.2 and 0.25, that is updating based on where I'm moving in the world space. I could move on infinitely into the void if I wanted to. But our main camera, its X and Y and Z aren't actually changing. Considered 0.45 and negative 1. What? What was the
Some
Oh, okay, someone's mic just. All right, yeah, that's fine. Sorry. It's only based on how far away it is from its parent. That's all it cares about. In fact, if I change this to 0, you suddenly see it's in the center on the x-axis. If I change this to 0, it's in the center.
this becomes relative to whatever
Yeah.
whatever object is parented to.
Right now, the camera is 0 away from its. The child is 0 units away from its parent. If we change this to 5, you see the camera's all the way over here now, and it'll follow that distance because it's 5 units away from its parent.
The parent will use the absolute world position, and all of its children will use the relative position to the parent.
Exactly. So after I exit play mode, I'm going to hit this at 0, 0, so it perfectly follows our player around. Or if I want to deattach it, I could just drag it out of there. Just drag it into some other place in the hierarchy, and now it's no longer following our player again. It's its own independent camera who don't need no parent.
Of course, parented objects don't necessarily need to be like tangible things. You could just have it be like a point where particles spawn from a particle system. Just a point that follows your parent object, like
Exactly.
for one have dust or something.
I could go as complicated as taking one of these other profile pictures and attaching a game object to another game object in that same way. The main camera is just another way to make it seem useful, but if we compile right here, you can see that that game object is now, it doesn't have any code to move on its own, but because I'm moving and it's my child, I drag it with me, no matter where I go. So it's a great way to attach stuff together. Another thing is, let's say I want to keep this weird nuance. Let me put this thing 1 unit and 1 unit away, just to keep it nice and close, so it'll follow me around there. I have this cool, complicated player thing. I've made the changes that I want. I put that back at a speed of 4, but now all that progress is not the same as the prefab that's right here that doesn't even have a child, that has a different speed of score. I can actually take the prefab that I really, really like, find it in the hierarchy here. I can drag it over the prefab that we made with this little gray border to help indicate that it's a prefab, and it will update everything about it. If I hit Control S, you see that this is blue, and its child is also blue because it's associated with that. If I double-click the prefab to open it up for editing, I can actually see in the hierarchy that the child is now part of the prefab. It has all the same settings. It has the speed of 4 and the score of 100 because I've edited it accordingly. Now, if I go back, I can actually drag the player thing prefab into the scene, and it'll come with the child now. With this relationship, I can instantiate all of these copies the same way. They still all move with their own children independently and the like. And that's how the game object parent-child relationship works. That is perfectly fine. You're not. Yeah, you're good. Samantha, you want to take over for now? I was just discussing. Hey, that's game objects. That's scripting. That's C#, and referencing components.
I'll just go on this project.
Oh yeah, sure.
Yeah, go right ahead.
Go crazy, mess around with anything you need to. Thank you for the heads up.
Yeah.
All right.
Mine was kind of just more fun little thing. I was gonna show how to do like a little menu and a scene change because I think that's fun. But I can also just do a little bit of UI in general. This is really small. So if you go to the game object UI, we can make a canvas. And it shows up over here.
The canvas
Really
is
huge.
very large.
This is a giant canvas. We can make them smaller. No.
It's supposed to stretch to fit your entire screen, so it's
Yeah.
not actually big. It's just that much. If it
Right.
helps, if you double-click an object or you press F on it, that should focus it to fit the screen. So if you want to go back to Dawn real quickly, you can double-click or vice
see.
versa. You should be able to. Yeah,
There
so
you
we'll
go.
zoom in on that. So if we double-click the canvas, we should be able to whoosh back out. There we go.
There we go.
Especially useful in 3D. I keep saying that.
Oh yeah.
Yeah. So if we want to, we can add text to this. We can add images to it. They're all under the UI. And then we could just add.
You may
I
or
guess
may
you
not
just got
have
Text
TextMesh
Mesh
Pro.
It'll ask if you want to
installed.
import it. It's fancier text.
Go with TextMesh Pro.
It's pretty good.
It lets you do more with it.
but of course mine's just
I don't know.
there by default.
Let me move in. So we've got a text object. We put whatever we want in it. The yeehaw. And we have all the normal text editor things. You can change the font. We don't have any fonts loaded up. We can change. We can make it bold, italic. We can underline it. We can strike through it. We can change the size. We can even change the color. Make it inline, and this will show up on our whole screen every time we play.
That's a perfect.
And it'll
line.
just say right there in the middle. It'll say wherever we put it. So like, usually you put like your score, but I like the yeehaw. We also have, we can add an image to it
It's under UI.
under
Yeah.
UI. I just can't see. And we can just use one of our other images that we already have. If I want her to stay up in this corner and watch us the whole time, we can do that. And when we press play, there she is. She'll stay on our screen wherever we move. I forgot you changed it to Z.
Also appear over top of everything, I think, actually.
Right. If we even parented our camera again, go ahead, open that up. I just have to like unpack it. Just to show that even if we move our camera, well, it didn't work.
I think because if you Control Z a couple times,
Yeah.
back to when it was, okay, there we go. If you double click on player thing as the prefab in your assets, then you can edit it, and you can add a camera through here that'll follow it.
Okay.
And that is just at the bottom, camera one tick from the
Camera.
Nice. It'll have the same default settings we had earlier. If you go back out, if you delete the other player things so there's not a bunch of cameras, then it should be fine. So player things 1 to 4, get out of here. And deleting the main camera as well. So that's another thing.
Just made a
There's
new
only
camera.
one camera that rides above the rest, unless you make some coding to make like a split screen Mario sort of thing. The scene will look for any camera objects, and it'll say, I want that one, and it'll follow it as best it can.
We
Where
lost her.
is... Oh wait, where's the camera actually? If you look at her position, the camera's position. Okay, so
Camera's
the camera's
here.
all the way out there. If you reset the cameras... Wait, yeah. Yeah, that's what are you missing?
You could put a camera as part of the preview.
Yeah, because then it would spawn in with it. But it didn't...
Oh, I broke it.
Not sure what happened. Wait, look at the camera one more time. See the clipping plane right there on the settings of the camera? This might just be a thing where in Unity it doesn't like to... It starts to clip because there is a Z-axis. It's a very strange nuance. If you make that maybe 11, just to be safe.
The near.
Yes. To see if something pops up. That didn't fix it. Darn. Okay. What are we missing? We could just Control Z back to the
Yeah,
main
I'll take it
camera.
back.
Honestly.
I was just gonna show that it would stay in the corner, the image I put on there, but
There's some setting about. Oh, there's the main camera again. What was interesting about it? Depth. Oh, right. Depth needed to be -1. Whoops. And now there's 2 cameras again. I don't know if it'll. What we get for creating our own camera? Whoops. My bad.
I never said we were professionals.
Disclaimer: we are not experts
Oh boy.
yet.
It's about whether or not you can't figure it out. It's not whether or not it is.
Well, doesn't matter. I'm gonna make a new scene anyway.
Yeah, new scene.
Yes, let's talk about that.
Yeah, so you can make multiple scenes. So if you wanted to make like a main menu, you can just go into, you already have a scene folder, and you can right click and create. Somewhere down here it says scene, right here. Make a new one. We can double click on that to open up. We can save the changes I made. And that just opens us a whole new scene. I'm going to again make a game object, UI, canvas. And on this one, if I zoom out on it, I want to add an image, which is also under UI. We'll just make it fill the whole screen. So that'll be our background. And we could put one of our images in here, or we can just change the color on it. Make it that color, it's kind of pretty. Then we can add text on here. We go under the UI again. We can make our main menu. I can spell. Set that up top. And then usually when you have a menu, you want to be able to do something with it. So if we go back to our UI, we can make a button. We can just put it in the middle here, and you can change all kinds of stuff with the buttons. They're really cool. Change color on it. Change text, which is under here. Make that our play button. That has all the same text editing that we had on our other text. With our button, we can change its normal color, and then we can change the color it is when you highlight over it. Change the color it is when you press on it. So that will show up when you press play. First off, it just appears red, but when I highlight over it, then it turns orange. And if I were to press on it, then it changed yellow and then white because I selected it. Change that one to yellow too. And then it'll change color like that. We can also add functionality to these. If we add another component, we make a new script. Make this one caps on main menu. So I made that. It's gonna load. I can open that up. Just double clicking on it. Now I'm gonna ignore these and make my own. I'm gonna make a play game.
It does have to be public in order for the button to be able to access it.
Yes.
The
So it should
play
be
game
under-
function.
Should be under the public class, or do I need to?
Under the play game function, yeah.
Yeah.
So the void functions are hidden in the inspector,
Right,
but the public functions won't be.
And this should be able to. I got the syntax. I wrote down.
The scene manager one?
Yes. So we have to
You do have
use
to-
the scene
yeah.
manager. So we also need to use scene management. I just copy that one, and then it's Unity Engine dot scene, capital S, and then management, capital N. That's just another library that Unity has used for UI. For the that one's not for the UI.
It's for the
moving
changing
the
one scene to
scenes
another.
around.
Yeah.
For managing the scenes.
For managing the scenes. So here, when we do the play game function, all I'm going to put in it is scene manager load scene. And we can hard code this. Nope. I am too used to my computer, I think. We can just hard code this and put in whatever our scene is called. So we made our new scene, and then our sample scene is our original one. So it's just quotes, and then whatever your first scene or your main scene was called. So mine was called sample scene. Need colon. That's simple. That's easy. We can also make a in-game function. All this one's going to do is when it's going to be application record.
Yeah, it doesn't take any parameters. You got it.
We save that. And we go back into Unity. That doesn't do anything yet because we haven't set it up to do anything. But I can attach that to our buttons. So if you open up your button, and you scroll down, you'll see this says on click, and there's nothing in there right now. If you add, it'll say during runtime only, which is when you press play. You should have.
It needs to know what object it wants to talk to for what script, so you actually drag the button into itself, similar to referencing your function.
I thought it was the script.
Oh, that's like the recipe versus the instance it needs to talk to.
Okay.
That's why it's asking for an object. So if you click and drag your button, you can drag it into there. There you go.
Okay.
And now you can access functions from the button, specifically whatever we've coded inside main menu, which is what our script is called.
There we
So
go.
it
So
looks
main
for
menu.
a script that's on an object, and now it can talk to that object. In this case, it's talking to itself. Now we see our functions pop up there.
All right, so that's under this no function. We find our main menu script, and then it has other stuff in here that just is Unity stuff, but ours is the play game. So all that should do, well, I'll check my build settings. So if you go into File, Build Settings, we've only got the sample scene in here. So we can add our other scene in. We can just drag it in there. That way both of them are in our scene. So then once I press play, it loads up. It's really thinking about that one. Once we press play, then it will go to our next screen. Can add another button. Just go to UI. Another button. Or I could have copied the one I already made. And this one I will name in the same thing. We are just going to add another on-click event. We'll drag that button in there.
This is actually a good time to showcase. You can actually add component, and it can be one of the scripts that we've made, or you can drag the script from your assets onto there.
Yeah.
Because it's a component just like the render image or anything else. So we'll drag our main menu script onto that, just like
goes
any
right
other
there.
component.
And then we can press our end game. And right now it won't do anything because the way that Unity is set up, it won't end the program while you're in the editor. So I'll set up a debug.log so we can see that it does something. Let's see.
Actually, I think it'd be really nice to end this off on a build so we can show that
You wanna
off
build
real
it?
quick. And then we can see it quit.
Once that loads, I'll show off that at least does something. Should print to our console, just our debug.log, quit. In order to build it, we go File, to go to our build settings, and then you would select what platform you're building it for. For us, we're just on Windows. And then you would have to hit build. It'll make a whole new folder. So you'll just put it in here. I got to save my changes. And then it'll load it all up and it will make an exe that we can just run. And it will just play the game. So ours should, it's actually going to open the main window or scene because I've set it up in here. It's got the sample scene first. So whichever scene you have in up here as the first one, that's the one it's going to open. So it actually won't open our menu scene because I didn't change that.
You want to do that really quick just to showcase the quit
You
button?
want to cancel it?
Yeah, it'll be fine. I can redo it.
Yeah, so for that, there we go. So if I unselect them and then reselect them, see that one pops up with a 0.
You actually drag them
Do I have to
up or
redrag
down.
them?
Yeah, so we can put that on top to give it a higher priority. Drag the first one down, I mean.
There we go.
There we go.
There you go.
So now new scene's the 0th one, and that's the first one.
We'll build it again. Yep.
Yeah, it takes even less time because it already compiled some stuff for us.
Oh, it says that.
Oh, it's going pretty good.
I've had status bars like me before.
It is flat out smooth.
It was that.
Project built with
Create Visual Studio. Any company.
build. That's interesting.
So for this, Hernandez.
You need to create a folder for it.
Right.
So yeah, this is just where we're putting the game. Game that you could pack up and put on Steam if you wanted to, you know? They accept pinball racing too. I'm sure they'll accept ours. All right.
If it builds.
Isn't the qualification for Steam mostly just like $100 fee or so?
They changed that for something else. I think there might be even less requirements. That was for the green light.
I thought it was after green light.
I don't know what they did after the green light. They removed green light. I don't know, more things going on Steam, I guess.
I guess that's to compete with other platforms like Itch.io, Squish.
There we go.
Now we do welcome everybody. Oh, nice! It has it.
So it's built now.
We have an
So-
application file.
It creates these other things that you do need, but this one's your exe. If we just double click on it, it'll open it up and play it.
If you
Made
use
with
the free
Unity.
version, all it needs you to have is that little bit of splash screen.
Looks like I did not have that over the full canvas.
Well, we can talk about stretching the canvas in a bit, but yeah,
And then
it
yeehaw.
works in there. I think if
We
you
don't have
alt-tab
any-
close it,
Yeah.
you can, yeah.
We don't have a
proper
quit
way to
event.
quit from here. If you right-click that instance that's running, you should be able to close it through there. Because we had set up the proper way for our game to close through there. But
I'm
if
like
we-
blind. If there's more than like 2 things on screen, I'm like, where is it? And
You
if
got
you
it.
wanted to show off the quit,
I'm sorry for having so many things on
You're
my
good.
taskbar.
There it is.
And then if
Now
I
it
press that,
actually
it
closes in application.
so really simple.
Zach, anybody else kind of using Unity for the first time? You guys, what were your thoughts, like how did it compare to like Python, Python for the?
Well, I guess like, because it doesn't even use the Python, you just say char. But
looking at C Sharp, I have actually seen it before. It's only because of like, or something close to it. It's just for like a website for editing that I have added. But and it's just I guess the UI is something I have to get used to.
It is definitely a lot to take in.
Have you guys had Maya yet? Like any of your like digital foundations classes?
No, man, that's probably fine.
I find this layout really similar to Maya, where you have like your assets at the bottom, your tree.
Speaking of which, I know we're over time a bit, but I do quickly have yeah. If I can hijack this for a second, if we'll just close these down for now. I can quickly show up what a 3D project would look like. And this was more of a test for what we did last semester for the teaching. This will take a hot second, but not too long. Now this is our typical 3D project overview. It would look like. Last semester we were trying to go for a more breakout in arcanoids by our concept. So we just have a table, a ball, and a paddle. There's not any like scripting up for here yet. But like with 3D, there's a thing to work with like turn the you can turn the camera around by holding right click, and you can also use WASD Q and E to if you hold right click and use WASD and Q and E, you can freely move around 3D space. This is a lot. I set up a more organized structure than what we did use. It's definitely good practice to have like preset folders for all your components. Like here I just have here's my folder for prefabs, which is this arena. This arena was built using right in Unity by using simple basic 3D objects like cubes. You can just spawn in cubes and such, rotate them, scale them. However, this whole thing this whole arena was just built with that. Got pretty obvious from how simple it looks. Yeah. But there's a lot of options here. Like basically what you would find is like default geometries in like Maya or Blender or whatever other 3D modeling software. This unfortunately spawns inside inside other objects. I have to drag them out. But yeah, these are also where these tools come in handy the most. And again, their shortcuts are assigned to the QWERTY keys. With 3D models, you also have these specific materials that you can use. These are like these are also like just built straight in Unity. You can also import stuff from Maya and Blender, of course. But for simple stuff, we just built everything through Unity. You also have like a default light source you can manipulate, and you can just coat different objects with materials. So that makes things really easy there. And of course, the camera goes for default camera. So basically, there's a lot more you can there's a lot more. What am I trying to say?
More you can do in the 3D. We try to keep it simple with the 2D.
Yeah, I think like 2D can and it'd be a good introduction if you were just familiar with like Pi game 2D and such, but but 3D Unity is kind of synonymous with the 3D aspects. That's what most people want with this. So
It does also have one of the best 2D engines that I've personally worked with on my projects, though. When it comes down to its physics simulations and the like, the fact that it's programmed in 3D but can be squished to a 2D space means you can actually still use mechanics like lighting and the like if you're clever with it. It's not something that's supported in other game engines, but it is just a note that although it does have a really strong 3D software, and it's a lot of value there with the physics simulations, more than just making games, seeing if buildings will crash or playing with new concepts. That it's pretty versatile and you can mess with it a lot. In fact, you can even hit that 2D button right there, and suddenly your project is transferred back and forth between a flat screen and the 3D view.
yeah,
That's
if you
something we
yeah
discussed
for
before.
and for UI and such, you will use this extensively.
Yeah. The only other thing about it is that when you create a 2D project template, it's made with certain settings in them. Like you saw our main camera started clipping at the end there because we made just a regular camera. That regular camera is ready for 3D viewing. We didn't make like a camera with the settings that are better for 2D programming, and vice versa. So just something to note about the templates and messing around with the views. Something to look forward to. Uh, is there anything else you want to discuss about this? Because if not, there is a small, like, 30-second note I want to make about the.
Oh, you go
asset
ahead.
store.
You go. I'm pretty much
All right,
done.
yeah, sure.
If I could steal this for another quick second.
Go ahead.
Don't want to hold you guys over for the game, naturally.
Yeah.
But just a little useful something. There's this window tab at the top here, right? This will bring out any windows that you closed beforehand. Whether you go in the general and you get the scene window again, the game window again, the inspector window again. You can drag those around and play with those, no problem. But something I wanted to talk about is the asset store. Unity's very open source. It wears that with pride, and there's a lot of collaborators, people that make stuff all the time. We can search online, and we can straight up download 3D style stuff to place around our game. Stuff that costs a little bit of money, but it's very worth it. VR controllers and the like. There's a lot to look for. If you're making your first game, it's best to learn by example. You could get a crazy $90 IK, or you can get free sounds, audio effects, particle effects that people just do for free. It's a collaborative project, you know? So just something to keep in mind if you want to participate in the first game jam with Unity is that you can get a lot of stuff done. I'm actually going to...
There's a lot of free assets. If you're just messing around, you can plop like a car in there and start messing with the wheels and see how that works.
Yeah.
This is also a lot simpler, the UI here, than like Unreal. Unreal will like open up a bunch of different windows, which I personally hate because I can't keep track of them. So I think this is pretty simple.
Unity is
It is
fairly
a lot
clean.
to take in.
All right. I know that there is a built-in first-person camera controller. It's amazing, but I'm not sure where to find that. Give me a second.
We're plenty overtime anyway. I think we
Yeah,
should
okay.
wrap this up.
Can't quite find it there. But I know there's stuff like that in the game store where you download this chunk of code, you throw it in there, and suddenly you're getting these like footstep walking sounds. Your character can jump, move around, and look around in the 3D space like a first-person shooter or a horror game, or however you want to interpret that. There's a lot of ways to make the same thing. The way we made our characters move around is by manipulating the transform component, but you can make characters move with physics. You can make them move while other objects command them to. There's a lot of ways to skin a cat, right? There's a lot of ways you can get something done in Unity, and that's why I think it's a great introduction for the 1801 ETGG is even though I personally did not know what you're supposed to do for a lot of stuff in Unity, I was still able to make mechanics and UI and mouse input and the like, oh, there's a function for that. I didn't know, but Unity has that flexibility where if you're creative enough with it, you really can make stuff work. So just the note in mind, you can play around with it. The documentation is very strong. If you ever look in a generic concept, you don't have to know the exact name. You misspell asset manager, and then it thinks you're probably looking for the asset manager, right? And gives you the relevant information you need. The tutorials online, there's millions of them, and I recommend giving them a look sometime or talking to our professors or other students, because we're always happy to help and show off what we've learned this semester. That's that.
On the note of the asset store, you can find deals of assets and such on websites like Humble Bundles. You can
Yeah,
find
that's really good.
and they
Polygon
they
for
often
materials.
put a bunch of bundles starting at $1 for basic package of that various different assets. You can get hundreds of dollars of assets for like $20.
And
or
Unity's
something.
great about it, yeah. You can just drag and drop that stuff in too. It's amazing.
Definitely don't rely on that, but
Well, not always, but Unity also has another tab at the top that's just like package manager. Click, import this package. As long as you've downloaded it from the asset store through Unity, Unity will know where it is. You download it through me. Oh, yeah, I put that right there. I know where it is. You can look it up, no problem. I don't think there's really anything else to talk about. I'm just excited to see you guys participate in the game jam, maybe. I'm happy to teach the lecture with our fellow junior ATGG 3802 students.
Yeah. So, big thanks to Max, Paul, Samantha.
All right.
Pick up their Friday and phone you to the.
I cut literature class for this. Let's go.
Pick up you guys for second your Friday too. Mark character.